Well, I'd like to welcome you to the third section of our practical problem solving clinic, understanding variation to solve problems. You can see from our agenda, part 3 has two sections we're going to be discussing in a few minutes. Section 5, tips on using control charts, and section 6, where do we go from here? So let's get started. Tips on setting up control charts. Well, you can see a control chart there on the right-hand side. You should be familiar with the control chart by now if you've seen the SPC module that we have. So there are many ways that data can be grouped to form what we call subgroups. And you see by the blue arrow there, that's where we we record the subgroups, the data that we collect in subgroups. Dr. Walter Schuhart said that the decision on how to form these subgroups are critical to the success of the chart, and he's absolutely right. He coined the term rational subgroups to suggest that some thought should go into the selection, and hopefully we'll be able to help you with those thoughts. So some criteria for forming rational subgroups are, besides the criteria of time, you're going to select data, and then when are you going to select it next, in the next 15 minutes, the next 20 minutes, the next hour. Please understand that there is no set form or no rule for when you create your next set of subgroups. When you're thinking about it being in time, think about selecting this subgroup in the next time before the process is changed. For what I mean by that is, if you think the process is likely to change in the next half hour, you should take a subgroup perhaps in the next 15 minutes. So some criteria for selecting subgroups might be by different machines, different positions on molds or dies. It might be something to do with tooling specific collection of data, or by the operating department, the production shift, by the operator, the gauge. Many, many different ways. It's really up to you to design the control chart so it tells you the information that you want, and you need to think about how you collect that data so that you can get the most information out of it. I'm going to give you a couple of rules for sure for you to follow. So Dr. Schuhart, again, said that depending on the criteria we use, the within and between variation takes on different meaning. And we went through the discussion about within variation and between variation in part 2 of this presentation. So recall this discussion in session 4, and it's really, really key to understanding Dr. Schuhart's recommendation on rational subgroups. Two major rules for forming rational subgroups for average and range control charts. Rule 1, form subgroups so that the members of the same group have the best chance of being alike. If you recall in section 4, we talked about taking consecutive samples because they're the closest alike that you can possibly get. So within subgroup, you want to minimize the variation within the group. You want the parts to be as close as they can to each other, like the set of triplets you have there on the right. Rule 2 is form subgroups between subgroups so that they have a maximum chance of being different group to group. So within the group, you want them to be alike as possible. Between the groups, you want them to be different. Just like that group to the right, they're significantly different. Two rules. Forming subgroups within the subgroup, you want the parts to be alike. Between subgroups, you want them to be different. So rule 1, minimize that within variation. Within variation becomes a measure of the process potential. It's really the best that the process can run. So we want to understand that. The within variation represents that noise factor, that unexplained variability. It's an estimate of the system or common cause variation that's part of the process. Minimizing that within variation makes the chart sensitive to assignable or special cause of variation so that you can understand or see that when a special cause variation exists. So maximize the opportunity for between variation. So high levels of between variation become an indicator of the presence of an assignable or a special cause. And you want to know that. So sampling is designed so that any anticipated changes will occur in between subgroups. That assignable or special cause is ideally exhibited as shifts in the process or trends as they become a signal as opposed to the noise. You follow that electronic analogy of signal versus noise. The between subgroup variation is a signal as opposed to the noise that's within subgroup variation. So in setting up the control chart, it is important to give some thought about how the subgroups are going to be formed. And we should choose groups to minimize the within, maximize the between. We also need to decide whether we sample by order or by some other criteria. And the point is, in this section, think about how you're going to arrange and collect the data because it's critical to the success of your control chart. So where do we go from here? So this module has hopefully given you an awful lot of information and a lot of food for thought. Problems, or euphemistically opportunities, are either selected or assigned to us because our performance differs from some expectation, either our own or someone else's. It's our challenge to describe the problem and use the process product data to close that gap, to make things better. So once we've identified that type of variation that is causing the problem and we've separated it into various sources, we need to determine which source will we attack first. Which process parameters control the output of the system we are studying, which really are driving the process. And what tools will we use to correct the problem? If we've properly identified the type and sources of variation in our process, we should be able to determine where our work takes us next. The package of tools that we've been talking about in practical problem solving is aimed at reducing that variability with the result of reducing cost and simultaneously improving quality. For this reason, the cost of variability should be key in charting our path. A team approach is the best way to form theories regarding which process variables control the output characteristic. Those theories then need to be tested and proved. The basic approach we talked about is Deming or Schuhart, plan, do, check, act, in conjunction with techniques that we'll be discussing in another module, like designed experiments. So use of control charts for studies. We've seen how control charts can be used to control a production process and to identify sources of variability. Control charts can also be used to conduct studies by tracking the relationship between process output products and the process variables in some kind of systematic fashion. Once the source of the problem has been identified, your practical problem-solving team turns to generating possible solution. There's no simple task method for this task. We rely on the knowledge of our operators and our support staff who know more about the process than anyone else to develop potential solutions. Use the strength of the team. Oftentimes, picking the best approach is not easy. So employ techniques like rational decision-making process that we showed you in the 8D video. That comes in handy when choosing the best option of many possibilities, because it may not be exactly clear what to do. So some problems can be solved by making a one-time change. They may be expensive, but they also may be simple. For example, a change to an established product design, a change in a component specification, a change in material grade or quality, a change in the method of measurement, a change in the method or procedures that you're using, rebuilding or retooling of existing equipment, investing in new equipment, or a change to new or upgraded process technology. All these are significant, and it's more likely that they'll reduce the variability that you have in the process, therefore immediately improving the quality and reducing cost. Albert Einstein once said, "You can't solve problems with the same kind of thinking that created them." So think outside the box. Think about different ways to solve the problems. Again, thank you very much for your time and attention, and please look at these references and credits. Again, thank you very much.